Smartboard's working. Okay. So if we're trying to find the lowest common denominator, the fastest way is to multiply these. That would be a horrible mess. Okay? Instead, if we identify and we factor this completely as much as we possibly can, look for the common factors, all right? Then we can basically ignore those and look for what's missing and multiply it through. So we'll see how this process works. On the bottom, it starts with factoring. What's a common factor of the denominator here? Anybody?
3x.
3x, right? 3 is a factor of 3 and 6, and I have an x here and I have x squared here. So when I take the 3 away from 3x and an x away from x squared, and I divide that out, I'm left with just x. If I take the 3 away from 6, I'm left with 2, and if I take the x out that's here, that's all I have in the denominator. Over here, a quadratic trinomial perhaps can be factored into two binomials. Worth a shot with an x and an x here. I need two numbers that multiply to be positive 4 and add to be negative 4. That would be negative 2 and negative 2. Now when you look at these denominators, what's missing? This has a 3x and an x minus 2. This has 2x minus 2. So let's look at this first. What don't I have in this denominator that I do have over here? A second x minus 2. So I'll need that over here. And then remember that whatever we do to the bottom, we have to do to the top. We're not actually going to add these because it's not asking us to, but don't just want to do that for consistency's sake. And then when I have this original denominator here, what was missing from over here? 3x. So I would multiply this by 3x on the top and the bottom as well. So my final denominator would be 3x, x minus 2, watch this. X minus 2, quantity squared. I have two x minus 2's, right, as binomials, so I can say that that is squared. The entire binomial is squared. Not to be confused with the difference of squares and conjugates, that's different, right? Last but not, woo! Did you guys see that? Last but not least, let's do this one. Let's keep rolling. Keep rolling. Keep rolling. Okay, here we go. Finding a common denominator here, like we said above, let's write the factored form of these denominators. The prime factored form of this denominator is 2 times 2 times x squared times y. Now I could write x squared as x times x, and that may help, okay? In fact, why don't I do that? You don't have to, but it may help for those of you that are still struggling with this concept. That is the prime factored form. When we talk about prime factorization, you're taking something, some product, breaking it down into its smallest possible factors, right? So that technically would be as small as you can get in each one of these values like this. So over here on the right, that would be 2 times 7 times x times y, right? xy cubed is not xy, xy, xy. xy cubed is x times y times y times y. If I wanted to write xy, 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 that would be written like this, right? The quantity xy cubed, where I'm cubing that 3 times. It's not what's happening. Remember, the exponent is only, quote-unquote, attached to the base. If I have a base of 2 terms, they would be parentheses there. Keep that in mind. So, we have our prime factored forms of the denominators. What do I have over here that I don't have over here? A 7. Anything else? What else do I have? 2 extra y's on this side. I've only got 1 y here. I've got 2 extras over here. So I'm also going to multiply by y squared. Now I've got y cubed, 2 x's, 2 2's, and a 7. Now come over here. What am I missing? This has a 2 and a 7. Now I've identified this is what has to be in my denominator, right? So it has a 2 and a 7. This only has a 2 and a 7. So I'm going to need a 2. This has 2 x's. This only has 1. So I'm going to need an x. This has 3 y's, and I brought these y's over here. So I had 3 y's on this side as well. Am I forgetting anything? 2, 2, 7, 2, 2, 7, 2, 2, 2 x's here, 2 x's here, 3 y's total, 3 y's total. So we're good. So when we put this back together, on the top, y squared times 7 times 5 is 35 y squared. On the bottom, 2 times 2 times 7 is 28 x squared y cubed plus 3 times 2 times x, that's 6x over, I know I'm good here, and then we add these together. I write it as a sum, even though I can't add them together. That's okay. That's okay. And as far as factoring is concerned, factoring and simplifying, we said this yesterday, you don't have to worry about simplifying your sum or difference if you found your common denominator correctly, your lowest common denominator. If you just multiplied these, if you did, from the very beginning, if you did 4 times 14 and got 56 x cubed y to the 4th, and you did that, then you would have to factor out and simplify, okay? Because you weren't finding the lowest common denominator. This is, to go back to the parlance of those times, simplest form of the fraction. So it cannot be simplified or reduced beyond this because it already has its lowest common denominator.